Yeah. We know that some of the operational users are risk averse. We know that they want to see missions and technology demonstrated on someone else before they do it on them, which raises the broader issue of demonstration infrastructure and what kinds of things are needed.
Hello, everyone. Welcome to the Space Policy Show. I'm Colleen Stover with the Aerospace Corporation. Today is part 4 of our season on ISAM. That's in-space servicing, assembly, and manufacturing. From the basics of what's involved and how stuff works, to the importance of collaboration and making standards and guidelines at the international level, all the way to humans versus robots. I'm doing my robot dance for people on the podcast. Today, however, we have a discussion on U.S. national strategies for building a more robust and more cooperative ISAM enterprise. Greg Richardson is from the Aerospace Corporation, and he caught up with his NASA counterpart at a recent Cosmic Kickoff event. Cosmic is the Consortium for Space Mobility and ISAM capabilities. So think civil and defense working together with industry partners. It was created and funded by NASA, but it's managed by Aerospace, and Greg is the executive director. He talked to Trudy Kortes. She's Director of Technology Demonstrations at NASA's Space Technology Mission Directorate. Let's listen to their conversation.
Well, thanks, Colleen. Thanks for that intro. I'm here with Trudy Kortes. She is the Director of Technology Demonstration Missions at NASA STMD. And Trudy, you've got a long background in in-orbit servicing, assembly, and manufacturing. Can you tell us a little bit about what NASA's been doing and what's in your portfolio for ISAM?
Sure, Greg. First of all, thanks. It's great to be here with you and talking about this topic that we know and love. In technology demonstrations, we're a very significantly sized portfolio. About half of what we invest in is dedicated to OCM work. We have some assembly and manufacturing work that we've done, mostly terrestrial based on the ground. And then we have a very significant amount of work in on-orbit servicing, assembly, and manufacturing focused on refueling and rendezvous and docking with a client satellite that was never designed to be serviced. And so we actually have a spacecraft in hand. We've got robotics and tool drive systems that we're integrating with that spacecraft now, getting ready to take that through an integration and test phase, and then projected baseline to launch in the mid-2020s to help further, what we're doing in-space servicing, assembly, manufacturing.
So we've talked a little bit about what NASA's doing, but we know that NASA is just one of many different federal agencies that have work in ISAM. Can you talk a little bit about the national level need for ISAM and what has been done at the federal level to try to bring these different agencies together?
Sure. So, Greg, back in 2022, there's a national strategy around ISAM that came out, that was published from the Executive Branch Office of Science, Technology Policy, and it lays out a framework for furthering ISAM and really trying to promote ISAM, and has some 6 kind of common goals and objectives that we're all working towards, and that was developed by an interagency working group within the government. So that's out there, and then shortly after that, a national implementation plan came out on the heels of that, about 8 months later, to talk about specific activities that can be done within the government. So at the federal level, we do talk on a regular basis amongst each other about what needs to be done. And we're all at kind of various levels of technology advancement. And I've had some really great discussions with some counterparts on the national security side about their needs. And they've toured some of our facilities. They've come to some workshops that we've had in the past where we do offer subject matter expertise, information about what we're doing in our projects. And likewise, they'll offer us information about what they're doing on their projects. And some commentary that's been made to me in the past is things like, when looking at the advancement we're doing in technology and things like our robotic operations center that we have at Goddard Space Flight Center, which is a really incredible facility, by the way. I've heard them say, comments such as, "You're so much farther along than we are in this. It's really great. We need this too." And so then I say in return, don't duplicate those things. That's really not what we should be doing, but let's use that and talk about how we can collaborate on this so you can use what we've done, for your needs as well. So to me, that's a really great conversation, an example of a conversation that we've had in the past. The other thing I'll say too is we've got principal technologists and system capability leads at NASA, specific to robotics, ISAM technologies, rendezvous and proxops, which all play into the ISAM world, and they keep a bead on what's going on externally to the agency, with industry, with academia, with other government agencies. So they have that information, and they take and we take that information and look at it to synthesize what we do, where we make our investments, and it also gives us a great roadmap on where we need to go. So that's really helpful too. The other thing I'll say though is I think we really need to look at kind of the pull, the mission pull within civil space. And I think we need to do a better job maybe communicating what that is and just information about that within the civil space industry.
Yeah, and you talked about mission pull within the civil space, but we know that a future in-space logistics architecture or in-space surfacing architecture would be beyond just civil space. And so on the DoD side, audience might be familiar with the term called Space Access Mobility and Logistics, or SAML. They might hear the terms dynamic space operations, and these are things that the DoD is looking at that are near-term applications for ISAM.
Right.
Can you talk a little bit about where you see the challenge come in as far as how to make sure that the DoD needs for their in-space maneuvering, for their space mobility and logistics, and for the applications they have line up with what the civil applications are that you're talking about?
Yeah, so first of all, just so our audience is aware, I'll just make sure it's clear that they're keeping eyes on our refueling demonstration. I think that's what they would tell you is most compelling to them that they need for their future missions. And if you look at kind of the suite of ISAM, some of the things that we talk about within civil space are examples would be missions where you're building the next great observatory in a space environment. And some of the larger scale things that we have that we need to do for habitation and things like that. How can you take up what you need and build in an on-orbit or in-space environment? Ours align maybe a little bit more towards some of the history we have on things like space station, the assembly and the manufacturing in space, whereas I think our refueling needs are more down the road than theirs are. I think when I say they, I mean national security space. That's more immediate. I think ours, will get there eventually, but right now I think there's some more immediate needs that need to be addressed, if that makes sense.
Yeah, and I love that you brought up the International Space Station, because NASA has experience with servicing, assembly, manufacturing, both in things like Hubble servicing missions, where astronauts went up and upgraded, repaired, and made sure that Hubble remains a world-class observatory here 30 years after launch.
Right.
NASA has used in-space assembly to put together the ISS and has manufacturing demos on the ISS.
Right.
One of the things that is really coming in the last few years is this push towards finding a way to do many of those activities robotically. And so there are certainly technology challenges that need to be addressed, but NASA has a lot of history in doing this. What are some of the things that you see to transfer some of those lessons learned about both what has been done with astronauts and how to design for assembly, maintainability, and sustainability, and how we can apply that to robotic systems?
Right. So I'll just start off by saying that one of the most compelling things I've ever heard is our deputy administrator at NASA, Pam Melroy. She's a former space shuttle commander. And I've heard her say a few times that the more that you can plan for the future, the more you can have done by robotics and robotic systems, and the less that you need of crew time, the better off we'll be. And she says that from her former astronaut experience. Right. And not a lot of people think that way simply because they just don't have that, breadth of knowledge that she does, or that, practical lived experience that she has to bring that. And so we're talking a lot, right, about lunar surface infrastructure needs, because that is going to be building ground for us to go on to Mars. So what are those things on the surface of the moon that we can do robotically? And some people, I think, are still thinking, have crew go do those things that you would do for maintenance or, types of things for systems. And you're going to start off systems with power infrastructure, communications infrastructure that you need, first of all, to do the other things that you need to do on surface, planetary surfaces. Those are going to need maintenance. Those are going to need installation. Those are going to need some basics. Have that done by robotics, which is, of course, a very broad thing to say. You have to get specific about that, but don't rely on crew to do that. And then when you go onto the vision we have for Moon to Mars objectives, same concept. Maximize what you can do with robotics, and more limited. Also, some of those things that you would have done might be more dangerous situations than I think we even realize now to send crew out to go do. So why risk your crew when you can have robotics do that? And I heard someone say recently, we need to think of it as an and, not an or. You're going to have humans do certain things, you're going to have robotics do certain things, and you combine that up, and it makes, I think, a great plan.
Yeah, and that idea of humans and robotics working together is something that's critical to the future of where NASA sees it. Let me pull us back, though, to the National Implementation Plan. And one of the things that's in that plan talks about the need for robotics from commercial to be able to support a thriving commercial ISAM ecosystem. And so most of the times when we're talking to commercial folks, we're talking specifically about robotics and only robotics. Can you talk a little bit about where you see commercial going with respect to ISAM, what they're developing and what they need from the government to be able to pursue what they want to?
Yeah, so I'll go back to kind of an anecdotal story, but I'll go back to an experience that I had talking with a spacecraft provider. And I'll never forget this because it just made an impression on me. And it was several years ago now when they said, no one really wants to buy a one and done or, a one-time use, very expensive $200 million spacecraft, and then set that aside and buy another one for a different use. They want something that their commercial base, customer base wants something that is repairable, augmentable, refuelable, can move to different orbits. But how do you do that? That's then a service. So you're going to a service from a kind of an asset model while you're buying that. And so I think that transformation is that's what we're talking about with ISAM is that exact transformation. And I'll also stretch the answer to your question a little bit to have this apply to the on-orbit or orbital debris problem that we're starting to talk more about at a national level in the national conversation, and just some concerns about that. And how many assets, and I've heard different numbers about the number of spacecraft up there and about how many, but it's a big number of how many spacecraft up there, 8,000 to 10,000 I've heard, and half of those are not functional right now. So how do you deal with that? And it's both the big and the smaller orbital debris issues we have. And all of this ISAM work ties to that. So it's, I think, multifaceted, a lot of different prongs to this, but getting away from individually used spacecraft and more towards a model where you're buying a service and then keeping your asset going for longer.
And I'm so glad you brought up the issue of orbital debris, only because the technologies needed to rendezvous, dock with, capture, and then move those pieces of orbital debris are often the same ones that you do when you're trying to rendezvous, capture, and move an active client spacecraft that needs to be in a different orbit or who's not trying to use its own fuel. There's a lot of technology overlap between those problems. But one thing that active debris can do is help us with testing technologies on orbit, right? Because we know that some of the operational users are risk averse. We know that they want to see missions and technologies demonstrated on someone else before they do it on them, which raises the broader issue of demonstration infrastructure and what kinds of things are needed to help make sure that these technologies are mature and ready for operational capabilities. So can you talk a little bit about the role of both infrastructure and logistics in an ISAM ecosystem and how that might apply to the type of missions that we've been talking about?
Sure. And I'll just pause here for a second and say, too, I mean, you also have a lot of experience in ISAM. So you're asking me, but there's questions I would also throw back to you.
Yeah.
So I'd like to hear your thoughts on this as well. But again, some of the infrastructure, you're gonna talk, first of all, terrestrial base versus, on orbit. And look, I'm in the business of technology demonstrations. That is my line of business at NASA. So what we like to see typically is an on-orbit demonstration, especially where you need a microgravity environment to test out some of these things. And so again, you might have ideally a spacecraft that you're going to fly and demonstrate. And I would say with ISAM, because it's push technology, you're not going to go, some of our technology demonstrations, we feel comfortable taking the right amount of risk and putting them right into an operational capability. This is not that case. I'd say, I don't really always love the phrase build it and they will come, but I think that does apply here. You're going to have to demonstrate some things to buy down the risk, some of those robotics things, the rendezvous and prox ops. And some of that's, human in the loop. There's still some teleoperated things going on with interface on the ground, especially when you are rendezvousing with your spacecraft. So some of those types of things are needed in terms of demonstration infrastructure. And again, there's some things you can do on the ground where you don't necessarily need a microgravity environment. And we have plenty of facilities at NASA, thermal vacuum chambers, robotics operations centers, where you can do things like approach and mate, to systems. But you're not going to get all of then the benefits of what we like to say the relevant environment. So you can mature your TRL from low to mid to high to make someone comfortable buying something that might be a little bit risky. So, but I'd like to hear your thoughts on demonstration infrastructure.
Yeah.
too.
So from my perspective, I've worked on-orbit demonstration missions before in the past, and one of the things that you always try to do there is figure out what's new, what you've done before, and where you need to buy down the risk.
Sure.
And so every mission that you put up that's a tech demo has some parts that have never been done before.
Absolutely.
And every mission that you put up has something that is getting to the point where it starts to become routine. And so what I would love to see is a mechanism by which we can help make some of the things that right now are first of a kind more routine.
Yes.
And in-space infrastructure can do that. And you
Yeah.
mentioned autonomous rendezvous and docking. You mentioned capture. You mentioned fluid transfer. These are things that we would love to be able to do from a routine perspective.
Yes.
But in order to do that, we need to do them not just once, but over and over again in a repeatable fashion, ideally demonstrating what's new each time. So if different companies have algorithms or sensors or certain ConOps that they want to approach, it would be great to be able to demonstrate them in the relevant environment, buy down the risk so that that particular system, that design, that capability can become operational.
That's right.
And so that kind of infrastructure would really help us.
That's right. And yet, you have to do something the first time and then make it repeated.
Yeah.
And that is always the hardest part, I think, because you really, again, you have to look at, I used to work for someone, an outstanding leader who I really think a lot of, who always used to say, you have to take smart risk. It's not just taking any risk, you have to take smart risk. And so really thinking through that. And that's always stuck with me, and that what you just said there reminded me of that a few minutes ago. So
yeah, and I love that idea of smart risk, because that tells you that it's important to be able to identify what's new, what's unique, what are you doing for the first time.
Yeah.
But I also love that idea of you have to take risk. We can't get to a point where risk is something that is always avoided.
Right.
But let's be smart about where we put it.
Right.
And different types of customers, different types of clients might have a different perception of where that risk is. And so one of the things I wanted to ask you about was just in terms of future missions, and not just individual missions, but entire ecosystems, right? That all of those type of systems might provide a demand signal for the type of technologies and capabilities. So where do you see those kinds of ecosystems coming in when it comes to ISAM? Do you see a robust in-space market for on-orbit services?
So I think that is the $20,000 question, isn't it? I think that we're all wrestling it with, and I think it's circular at this point, right? And you could make an argument that, I've seen numbers that say it's a $2 to $3 billion per year industry, but you have to make it so, right? You have to get to the reality of that.
And you need to buy down the risk so that someone's willing to
Right.
purchase that service or
Right.
create that opportunity.
So I think 100% yes is the answer to your question. But it's a huge hurdle to overcome. And I've said this about other technologies we're trying to develop too, is getting from a demonstration to an operational capability, in my estimation, is the biggest hurdle to overcome. Because I have seen where you demonstrate, you need another version of it, you might make some engineering changes to it, and that's a whole other issue. But but there are a lot of different scenarios you could foresee in the types of things where you need on-orbit manufacturing. Again, you want to use planetary surface, types of resources that you have, regolith, or to make large structures, right? Things like that. So you're going to have that aspect of it, and we're talking a lunar infrastructure that's significant activity. Launch pads and things like that. That's all going to take robotics, right? That ties into our ISAM, vision. And then the assembly piece, again, maybe making things and assembling them while you're up there. Apertures, large-scale apertures, solar arrays that you might want to make on orbit while you're up there. Making the beams. Structural beams while you're up there. And then you get into how do you validate that? How do you test that? How do you verify that on an on-orbit environment where we're used to doing it on the ground?
And on the ground, you've got a ton of different facilities and ConOps, and we do all of that
and
now.
Eyes on it,
and exhaustive testing.
Right.
We do that in space,
and
not something that's assembled or manufactured.
Yeah, so you have methodologies to do that on the ground that we have to start thinking through, because it's just a total different, it's totally different paradigm. It's just a shift in how we do things. Semiconductor manufacturing on orbit is something that's being talked a lot about too, and that it's more cost effective to do so. Are we doing it right now? No, we're not. Do we have to convince some people? Probably, but is there industry, do the economics of that make sense? I know smarter people than I are looking at that right now, and the economics of ISAM. It probably can explode, Greg, you know that, right? But some of that remains to be seen.
Yeah, and I love that what you're doing here is connecting the needs of future users to the technologies that are needed and the demos that are needed. That's something that we need to do a lot more of, is connect research and technology with the mission users and make sure that users are developing based on what exists today, and that the future research and technology is based on what future users and current users are going to need. So it's that communication pathway to make sure that we have those connectivities in place that's really going to make a big difference.
Right, and I would be remiss if I, as a NASA person, didn't talk about our Moon to Mars objective. So I've already talked a little bit about lunar infrastructure, but then that journey to Mars, the trip that we ultimately want to take, that is a long trip. Even if you're using some more rapid transit types of technologies. And humans to Mars, which is an ultimate goal, you cannot take everything with you. So what are the types of things that you need to make on orbit? What about pharmaceuticals? What about surgical equipment? What if someone gets sick, right? So just the human factors of all of that. There's an aspect too of that we haven't even really, I think, started to explore yet for those longer duration, human-based trips that we have in our future sites. And ISAM 100% plays into all of that and is, I think, going to provide not just efficiencies, but I think the means to the end. And again, it's a mindset shift. And I'm not sure we're quite there yet. Maybe we are, and I don't know it. So maybe I shouldn't assume that. But I think I think there's a shift coming.
Well, it's interesting you talk about the mindset shift, because one of the things that I think about is how do we imagine a future that's different from today? And so one of the things that comes back to is this issue of the next generation of scientists and engineers, right? And workforce development. What are the things that we as an industry can do to help make sure that both the next generation of folks understand more about ISAM and think more broadly and more big about what we can do in space, what's possible, as well as how do we take folks that might have been designing spacecraft without ISAM for years or even decades and help them to better understand. How do we address that from a workforce development perspective?
So I think you just said it at the end, but we should talk about that more. And there's a whole host of other things I'd like to talk about with regards to workforce development. But first of all, I think because that hasn't been the norm, designing certain things to be service, that's the first step. And then so in doing that, looking at engineering curriculums, our university courses, and how that's being promoted, right, and how that mindset shift happens. The other part, though, about workforce development, and this could be a little bit broader than ISAM too, I think is just what I would call leadership in an engineering environment, and kind of instilling that in even younger than universities, in higher education. I don't know about K through 12 maybe, but in the 9 through 12, the high school type of time frame. So I feel really strongly about this. And I'm on some different groups where we talk actively about this. And I think giving students at whatever level an opportunity to be on a project team, to understand how leadership roles work, how roles and responsibilities work, how to deal in a healthy way with conflict, how integration looks, how collaboration works. And I think giving them that experience before they get into the working world, I think is hugely valuable for us. And then if you relate that back to some of the ISAM technologies, again, there could be a lot of different areas that we need, but going back to things like basics, robotics, autonomous systems, some of those types of basics you need. And I keep going back to those two things, but it's broader than that. I think fostering that and finding ways to do that in this ISAM community that we work in, I think would be very valuable for us, in the future. And there's some other ideas around that too, but when you say that, those are the top things that come to my mind.
But that highlights for me just one of the things that I've heard you say a number of times, which is ISAM is a team sport, right? That ISAM is not just about a structure or a robot or a sensor or anything. All these need to work collaboratively and together in order to make that system function. And so giving students both the ability to think big thoughts and the ability to understand how to take those and work as an interdisciplinary, multifaceted group to go make those happen is really important. And so this idea of leadership models and how to integrate as a team and how to work as a team, that's different than a lot of engineers think. Their heads down and they want to do their analysis, but we can't do that. We have to think broader. We have to think about the intersection between disciplines, because that's where the challenges are, and that's where ISAM can get it. And it just highlights how important collaboration is. And the earlier they can learn about collaboration, the easier it's going to be when they need to go up and work something that's not just a team collaborating on a spacecraft, but one spacecraft collaborating with another to try to get them to do rendezvous, docking, and joint operations.
That's an interesting way to think about it. You have both the collaborative technologies that need to work together, and then just kind of the people collaboration. I like that. I like that analogy. And I'd just say too that I've gone out and I've spoken to engineering students before, and engineering colleges and different curricula, and I talk about some of these things with some of those different skill set than they're used to learning in their just engineering classes, and they're hungry for it. They're absolutely hungry to learn about this now, again, before they get into a working environment, because they know those are where the pinch points are. We can do the technical all day long. I'm convinced of this, right? We have the most brilliant minds. I've worked with them. I've seen them. I enjoy that so much. Just seeing some of the brilliance that is in our midst, and that I get to enjoy on a daily basis. It's those other things that we don't, we need to probably be talking about a little bit more, and fostering, I think, maybe at an earlier age, just to know how to deal with that in a good way.
Right, and I love that you're saying we know how to do it. We know from a technology perspective what we need to do, and I know that NASA has been investing in ISAM technology, has been maturing those capabilities, and has been building a workforce. One of the things that we need to do is to figure out how to apply that, right? NASA, there are lots of small companies, larger companies that are thinking about doing ISAM, and you talked a little bit about the tech transfer process that NASA is doing. How is NASA partnering with others to help create that commercial ecosystem?
So we have a couple of different ways that we do that. We have some, formal technology transfer programs, and then, we just have more informal ways that we do things. In some of the solicitations we put forth, one in particular is called Tipping Point, and that's a public-private partnership that we have. Will offer some NASA facilities, that folks can elect to use if they so, choose to do so. Subject matter expertise that we'll offer, because again, that's a collaboration there. But in tech transfer, we can also license technologies that we have in a catalog, and there are different ways to license things for startups, for new commercial, for if someone just wants to try something out to see how, if it will work for them. But we've licensed things like LiDAR. We've licensed some valves that are kind of a standard way of doing things. So we have a couple of different ways that doing that. I hope that is answering your question about
it does.
It's just there's so many different ways. I could probably talk about that for a few more minutes, but I'm not sure you want me to.
No, but it highlights this broader issue of how important it is to collaborate, and this issue of government collaborating with industry, government collaborating with other government. Can you tell us a little bit about other mechanisms and ways that we can collaborate as a national initiative towards ISAM? So
I'll just say that I think NASA has taken a very proactive approach recently to collaboration, and I'll just start with, this doesn't necessarily apply to ISAM, but the Artemis Accords. We have 30 countries, I think 29, maybe close to 30 countries now signed on to the Artemis Accords, which is our, focused on our human exploration program. But we say in that, but there's science to be gained here, but there's new technology we're using, so it's very broad. Artemis Accords is a great example of collaboration, but I know the agency is very interested in applying that broadly. So Lunar Surface Innovation Consortium, hugely successful. I've even lost count on hundreds of organizations that are part of that. And then based on that model, someone said recently, shouldn't we do something similar with that around ISAM? Because we need to bring everyone together. And until we do that, this is probably going to flounder. And we know that to be true. And so recently we've come up with a new consortium called COSMIC. You're well aware. You've been one of the founding members, right, with us. But the Consortium for Space Mobility and ISAM Capabilities, called COSMIC. And we're kicking that off now and going to progress into the future. But again, that's a nationwide alliance between academia, industry, and government, all these players, both users of the capability and providers of the capabilities, to bring different voices together. And I'm really proud of this work. It's been a really great effort. NASA kind of has spearheaded this, but it is not a NASA consortium. It's a nationwide alliance that we want to be owned by the broader ICM community and to have an active role in. So again, we're kicking that off. We have a steering committee, different caucuses between the different groups represented, and then some focus areas on where we think the main focus needs to be on different areas that we need to bolster, talk more about, and that will really make ISAM a routine part of our missions and space architectures.
And one of the things that I love about what you described and what COSMIC is doing is it's addressing the problems that we're talking about. It's addressing the challenges associated with better collaboration and coordination between government, across government and industry and academia.
Yeah.
It's addressing the partnership that's needed between the research and technology folks and the missions and ecosystems folks. It's addressing the specific workforce development and policy and regulation issues. And it truly is that nationwide alliance to bring us all together, help us go stronger together.
Yeah, it is really multifaceted, and it's going to take all of us working together to make this happen. And I know, because I've seen it, I've seen the broader aerospace enterprise in this country do this. I've seen us do it, and I know we can do it here with ISAM too.
So let's do it again with ISAM. Let's do it with COSMIC. So thank you all for listening, and look forward to seeing you at a COSMIC meeting soon.
Well, thank you to Trudy for letting us wrangle her over for a sidebar at the recent COSMIC kickoff event. This consortium will certainly be making some great leaps in the near future, so look for ways you can join them. I know that U.S. industry partners are all welcome. CosmicSpace.org. Check it out. And thank you to our audience for watching or listening. to our 4th show in the ISAM series. You can find other episodes on our YouTube playlists or wherever you get podcasts. You can browse all of the center's more in-depth research by topic area at csps.aerospace.org. And thank you to James Liggins, our technical director. Bye for now.